Everybody, I noticed that a lot of you were struggling a little bit with some of the in-lab stuff with the meshing on Wednesday, so I decided I'd go through and do a little example for you to look at in case you needed to go back and look at it. So I'm going to be doing case 2, just real quick for everyone. As first thing I'm going to do, make a new file, and I recommend this for everything. For every new part you do, you should put it in a new folder. So I'm going to make a new folder for the part, angled beam case 2, and this is where I'm going to save it. That way when I run everything, all of my files stay in the same spot. First thing we've got to do is obviously create the points. So there's one at 0, 0. There's one at 0, 6 in the Y, and then you've got 72, 6, and 720. One thing that I noticed a lot of you don't do is hit this little point size marker. Just makes the points a lot easier to see, especially when you got a bunch of them. It can be really nice in the future. After that, we got to create our curves. And lastly, we have our surface. You might be thinking, I needed 4 surfaces, just like I have right here. But I'm going to show you a tool to make those a lot quicker than you would with just making each of the points. So if you're in geometry and you go to edit, and you go to break, and then whatever thing you want to break, and you make your option parametric, then you can break whatever object you want according to this value. So if it's at 0.5, it'll just break it in half. So it's as easy as selecting that one surface and selecting these 2 surfaces, and you've got your 4 elements. Super easy. Alright, so last thing we've got to do is we've got to create our last little point here. So we'll just do that real quick. So we have 72, 0, and then 18. And then we have 6 and 18. Just create that curve real quick. And then our surface. And our geometry is all done. So the next thing you got to do is you have to make a material. In this case, we're going to be making a material steel. So might as well call it that. Input our properties. We got 3e to the 7 for our elastic modulus and Poissons is just going to be 0.33. Basically everything you make in this class will be steel. Might have aluminum and brass a couple times, but you should remember these numbers, that way it's quicker. And then you just hit apply. Easy peasy. After that, we need to apply that material in our actual shell. So we're going to come over, create our 2D shell. I'm just going to call it shell. Input our properties. And you can just click over here for material name. Choose the one we made. I forget how thick this is supposed to be. I don't just think it's 0.6. Our thickness, just make it 0.6. Hit OK. Now, don't forget to select your application region, something a lot of people did as well, I was noticing. You want to select all the members, so that this pick all will do that real easily for you. And after you do that, you cannot forget to hit add, otherwise nothing will actually be selected. So after you hit add, hit OK, apply, and now we have material properties on all of this. After that, we need to do our displacements and our loads. So let's call this wall for our displacement. Input data. We don't want this moving at all, so we're just going to put 0 in all the translations, 0 in all the rotations. Hit OK. Select application region again. Make sure you click the curve and not the 2 points, because if you do the 2 points, then everything in the center here will not be constrained. And if you have more nodes, it will make a difference. So hit add, OK, apply, and you see here that our displaced constraints have actually been added. So after that, do our force. Just call it force, why not? Input our data, and we want this to be point loads of 100 each at nodes 11 and 12. So let's input our data. Oh, it's already up here. And we notice that our force is actually going to be going in the x direction. So 100, 0, and 0. Select our application region. and you can select them one at a time, or if you want to hold shift you can select more than one as long as you're holding shift. Add them, OK, apply. And so now everything we need to do for the geometric model and the loads and displacements and materials is all done, and we can move right on to meshing. Alright, so you need to make a mesh seed before you make a mesh. So we set our mesh seed. I only want nodes at where there's geometry points and at the corners of the surfaces, so I'm just going to set this equal to 1. Then we got to select our curve list. I want everything to have the same mesh seed, so I'm just going to hit pick all and apply. After the mesh seed's done, we have to actually make our mesh. And so once again, I want everything, so I'm just going to pick all and apply. After this, a lot of people forget to equivalence. And so what equivalence does is, this surface right here has a node at each corner, but this surface also has a node at each corner. So these nodes right here, there's actually 2 nodes in each spot. So when I equivalence, it's going to run through the model, it's going to see all the nodes where there's duplicates, and it's going to erase them. So after I hit apply, you're going to see that 8 nodes are deleted. So there's 2 nodes deleted here, 2 here, 2 here, 2 here, 8 nodes, makes sense. After that, you can if you want. It's nice to do just for niceness sake, I guess. If you optimize, then it will renumber all of the nodes. So it might be 1, 2, and it deleted 3 and 4 here, so it's 1, 2, 5, 6. If you hit optimize, it'll just go through and renumber all the nodes. So you can hit apply and just get this out of the way. And now all the nodes have been reordered. And now that's everything for this. So we're just going to go to analyze, hit apply. It'll run through this real quick. Once that's done, we can just attach our XDB file. Make sure you're selecting the right results file. Hit apply. Make sure it says end attach result file here. If it doesn't, then you have to figure out what went wrong. A lot of times you didn't equivalence, so I'd go back, redo the mesh, make sure that's right, and run it again. If it's still wrong, then you're going to have to do a bit more troubleshooting, but 90% of the time that's the issue. And then you can finally go to results. You're always going to need a displacement plot, so we can do that one. And you're always going to need a von Mises plot, so you can also do that one right there. And that's just a real quick way to do all of this, so you can watch it. Hope it helps, and I guess I'll see you all on Monday.